the intro.
What are we saying?
All right, so good morning, Calculus 1. Sorry. Everyone else here is slackers for those people in Donkey Shake Town. Yeah, seriously, I do have people from Holland. Actually, like I pull up my YouTube and like my stats, and it shows me where people are actually watching it around the world. And I actually have people in Holland watching this, so I'm like, hey, I know, right? So yes, on my 4 views I got last week, one of them was actually there. All right, so okay, so now find second, third, and fourth derivatives of that thing right there. So now notation for this. So this, if my function is just y, my first derivative would be. Go ahead. Okay, but how would I call it though? If it's y, my first would be y prime. So the second one would be double prime. Very good, yeah. It's pretty simple. Double prime, and third one would be triple prime. Okay, so anyway. So we have that. So we said y prime would be what? 6x squared. Very good. Okay. Now y double prime. Y triple prime. And y to the fourth, or fourth prime, you either see it like this or you'll see it like y. You're not going to see that. Rarely will you see the notation ever like that. If you're doing all the way to the fourth derivative, you're only going to see y4. Okay? So, like that. Anyway, so fourth derivative would be 0. There we go. Now, in the case of everything that we're doing, so when we're talking about like the physics aspect of this, this is my position. This tells me where I'm at. So, the function is my position. The first derivative is my velocity. Velocity. I don't know, however you spell it. Okay. All right, so after I take velocity, the next derivative is going to be acceleration. And after that, okay, the derivative after acceleration is going to be Pitor. It's the jerk. It's actually the force in which that it's actually like pulling it at that second. So there's a instantaneous pull. So think of it like this. So have you guys ever been in a vehicle like towing a trailer, towing a boat? Okay, so when you guys start, okay, you start pulling it, and then as you start going, all of a sudden you could actually feel it hit for a second. You'll feel that jerk right there, and that jerk is the thing that's measured right here. So it's the change real quick. So it's an instantaneous change of how it's actually moving. So that's going to be the jerk on that. So does that make sense? So like training, yeah. So anyway. Okay, velocity. So absolute value of velocity is your speed. So how fast you're going. But it's possible to have a positive or a negative velocity. So a positive velocity and a negative velocity, the absolute value of that is your speed. But if it's negative, that gives you direction. If it's positive, you're going forward. If it's negative, you're coming back. Okay, that's your velocity. And acceleration, that means, how fast you're accelerating. Is it speed increasing or the speed decreasing? All right. Okay, so find the second and third derivatives of that. So what rule is that? Product. Very good. So I'm going to call it like it is. So F and G. F and G, right? F that G. All right, so let's take a look. So F prime. What's the derivative of F? 2x. Very good. Okay, G prime. e to the x. So in the product rule, so it would be f prime, so I'll rewrite it again. So it's going to be f prime g plus g prime f. So that's my rule for that. So if I'm plugging in my values, so it's going to be 2x times g, which is e to the x, plus g prime, which is also e to the x, times my f, which is going to be right here, 1 plus 1 plus x squared. There we go. And the only thing I could do is a little bit of factoring. So do they both have a common factor of e to the x? So if I take out an e to the x, I'm going to be left with 2x plus 1 plus x squared. There we go. I would just leave that be. Or the only thing I could actually do with it is actually rearrange to have highest degree first. So it would be an x squared, then x, then 1. But still, you know, at this current point in math, you know what, you don't have to do all that. Just leave it. Are we okay? Yes. All right, good. All right, so work with acceleration. Okay, for object of motion is distant s from the origin at time t, given by the function s equals s of t. So distance is normally referred to as s of t. The derivative of that is going to be, so the derivative of s at time t, so you're taking the derivative in terms of the t. T is your variable, s is the name of the function that you're using. So s of t is going to be your velocity, which is v of t. So the velocity, that's the first derivative in time t. Okay, acceleration a of t, that's a second derivative. That's the second derivative from this. Okay, second derivative of this. So a of t, so it's acceleration at time t, rate of change in the velocity with respect to time. Okay, so we could also call it as this. Okay, the second derivative, we could rewrite that as like this. So this means the second derivative. Okay, that's y double prime there. Okay, but the distance respect. Okay, all right. Now, this is a whole lot of problem. Okay, and it says a ball is propelled vertically upward from the ground with an initial velocity of 29.4 meters per second. Okay, that's the initial velocity, right? Yes.
Are we not going to find the second and third derivatives of the other one?
Oh, did we miss that?
Yeah, that's just the first one.
Oh, thank you, man. You know what? Here, you know what? You earned yourself some more candy. You need to learn to catch. You really do.
You did not even.
Okay, so there's my first derivative, right? Okay, second derivative. So now this is a product rule again. Okay, thank you. So let's see, product rule. So that means that, man, there we go. Okay, product rule. So that means that this is my f and this is my g, right? So f prime here. F prime for this one would be e to the x. G prime would be 2x plus 2. All right, so now we're doing again. So it's going to be so it's e to the x. I'll rewrite this to make it easier. X squared plus 2x plus 1 plus sign, and then it goes g prime, which is going to be 2x plus 2 times e to the x, right? Okay, so now factor out the e to the x again. So e to the x, and I'm left with, let's see, that's going to be x squared plus 4x plus 3, right? Yes?
Yes.
Okay, so that's the second derivative. And third derivative, I need scratch paper. All right, x squared, 4x plus 3. So we have e to the x, x squared plus 4x plus 3 All right, in this case, this is my f and this is my g, because we have to do one more derivative, right, to get to the third. Okay, we got the first, we got the second, now we need to do the third. So f prime, e to the x, g prime, 2x plus 4, very good. Okay, so let's do my thing again. So it's going to be e to the x, and then it's going to be x squared plus 4x plus 3, right? Plus, what is it going to be? E to the x, right? And it's going to be 2x plus 4. Okay, factor out that e to the x, and I'm left with, yep, x squared plus 6x plus 7, and this is my third derivative, so at y triple prime. So. And 4?
No, we don't do it.
No, yeah. So right here, it says second and third, right here, second and third. So, sorry about that. I know, right? Man.
It's not your day.
I know, it's not. It's not my day. I keep making mistakes. Man. I didn't have my V8 this morning. Anyway, height of the ball, S in meters of the ball, is above the ground is approximately this. So S of T, what did I say S of T represents? Position, right? So that's how high it is, right? Where T is the number of seconds elapsed from the moment the ball was released. Now, so let's take a look. Yeah, there we go. Okay, so S equals, I'm going to change back to red. So S of T equals, what was the numbers?
-449 t squared plus 29.4.
Like that, right?
Yeah.
Okay, so you guys ready? Now, what is the initial position of this? At time 0, think about this.
0.
Why is it 0?
You plug in 0 and it's 0.
Yeah, it is. So S position would be my height, right? At 0, so my initial position is 0, right? So if I plug in 0 at time t, I get 0 and 0, so it's 0. Okay, so because we're throwing the ball up, it's starting at 0. Okay, so what does the first one say? What is the velocity of the ball at time t? What is its velocity t at 1 second? Okay, so first, velocity. So we know velocity is the derivative of position, right? So I could actually, instead of saying S prime, so I could call it S prime, or I could also call it velocity. So I'm going to start with S prime on this one. Is going to be what?
Minus 9.8.
9.8, very good, 9.8.
Plus
T plus 29.4, very good. All right, so that is the equation of the velocity. Okay, that's going to be how fast it's going. Now, at 1 second, so the thing said S, keep trying to do that, S prime of 1, so I'm plugging in 1 for that. So I have to actually calculate that, right? I got to plug in 1 for my t, and so that's going to tell me it should be this minus this is going to give me what?
19.6.
Now, velocity. What are the units that it's moving?
Meters per second.
Meters, right? Meters per second. Because velocity is moving. Okay, it's King Julian from Madagascar. He likes to move it. So we always, when we're talking about velocity, especially when we're plugging in numbers for this, you have to label your units. Okay, go back in, find which units was given to you. That's your unit. So we're going to have meters. And time t was in seconds. So it's meters over seconds. All right, so we have that one. So I got my question 1. Okay, so I did that one. When will the ball reach its maximum height? When would the ball reach its maximum height? Now, we have to go back and talk about what our derivative represents. What does our derivative represent?
Slope.
Slope, right? Slope of the tangent line, right? So now, this is something you have to think about when we're doing these. The ball is being thrown up, isn't it? So if it's being thrown up, so it's going to look something like this, right? Yes? The maximum height would be when it goes to this spot right here, right? When it gets to that spot right there. Now, what is that slope?
0.
That slope is 0. Very good. That slope is 0. So when I want to find where its maximum height is, I need to know when the slope is 0. So what function am I going to use for this one?
The first derivative.
First derivative. Very good. I'm not going to use position, right? I'm not using position. I have to use the derivative. Because the derivative, the velocity, I want to know when a velocity is 0. Now, if you think about it speed-wise, so I throw it way up, okay, and it's going up, 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 and it slows down, slows down, slows down. And at a certain point right there, it's no longer going up, is it? It's no longer going up. So at that second right there, it's no longer going up, it stopped, and now from that point on, it goes down, right? So I want the velocity to be at 0, and it's going to, from that point, it starts going down. Okay, so now I'm setting the velocity equals 0, which is my first derivative here. So my velocity is going to be set equals 0. So now I'm taking this one, so it's going to be negative 9.8 t plus 29.4. So instead of writing my s prime of t, I'm going to set this over here equal to 0. Okay, I have to set the derivative equal to 0. And that's going to tell me when I'm going to get that. So what should I start by doing? Basic algebra here. Yeah, there we go. So it's going to be negative 29.4 equals negative 9.8 t. And then when t, I got to get t by itself, divide by, yeah, negative 9.8. So t is going to be about, it's about 3, right? Or is it exactly 3?
Exactly.
Oh, exactly 3. Oh, okay, all right. So t equals 3. All right, there we go. So now, yes?
No.
Okay, so when t equals 3, that tells me the time in which that this thing is finally going to hit its maximum height. Okay, its maximum height. So let's go back to the question. It said, when will the ball reach its maximum height? Okay, at 3 seconds. Okay, so we're going to say, so 3 seconds. There you go. So 3 seconds on that one. Question 3. What is the maximum height the ball reaches? Okay, we know when it's going to reach it, right?
Yeah.
But I want to know the height. So what is height actually asking for?
Like plug in 3 in the first equation.
In the first equation. Now, what did I call the first equation?
Position.
Position. Very good. I'm going to plug in 3 into the first equation, which is the position. All right, so my S of t was, what was it again? Plus
99.4.
t, like that, right?
No. Wait, yeah, I'm just kidding.
Okay, yeah. So now, since I'm looking for the actual height, how many meters up it's going to be, okay? The actual height. So now this is where we're plugging it in. So it's going to be S position at 3 is going to be negative 4.9 3 squared plus 29.43, right? Yes. Okay, y'all got calculators. 44.1? Okay, so we're going to say that S of 3 is 44.1. What are my units? Meters. Very good. And that's a height. Okay. So, what is the acceleration of the ball at any time? So we said acceleration is the what?
Double prime.
Acceleration is a what?
Double prime.
Double prime. So it's the second derivative, right?
Yeah.
Okay, so if we said that S prime of t was negative 9.8 t plus 29.4, right? And I want double prime, so that's the second derivative of the position. So S double prime of t is going to be negative 9.8. So, what does that mean? So, we said the second derivative represents the what? Acceleration. That's the acceleration. Okay? So what's acceleration of the ball? Right there. There we go. How long is the ball in the air? Okay? How long is it in the air? So, think about it. What function is going to tell me that? What function is going to tell me how long the ball is in the air? What am I actually, if I say air, you're referring to what value? Crap.
Why?
Think about, what did I do right there?
You wanna jump it again?
No, not really, because I'll probably lose it again. All right, so what am I doing?
You fall.
What function should I use? If it's in the air, I'm talking about the what?
The position.
The position, right? The height. Is that what you're saying?
No.
Okay, you're getting there though, right? Okay, yes. Okay, so if it's in the air, I'm talking about the height. Yes?
Mm-hmm.
So if I'm talking about the height, that uses position function. So that's the original. So, okay. So now right here, we have that one right there. So the position function. So if it's going to hit the ground, what's the height? 0, right? So if I want to know when it's going to hit the ground, I need to set the position, the height in feet, to 0. So it's going to be 0 equals position, negative 9, oh, yeah, 4.9. 4.9 t squared plus 29t. Now, I'm about ready to use an F word on this, and you guys better get it this time.
Is it 29.4?
Huh? Yeah, 29.4. Okay. Okay, now let's try it again. Okay, so I'm about ready to use that F word. You guys better get this one right. Factor, yes. Factor that. Do they have a common factor? Say yes.
Yes.
What?
T.
T. Take out that T. So it's going to be 0 equals T quantity negative 4.9 T plus 29.4.
That's if you do 2, you pull out, it comes out
Hmm?
even. 6. It's 6. You could have pulled out the 4.9.
I could take out a 4.9?
Yeah.
Oh, hells yeah. Okay, so she said take out a 4.92.
Or negative.
Yeah, let's, do you know what, yeah. So negative 4.9 T, and it's going to be T
Plus 6.
minus
Minus 6,
6. There we go, okay.
Ta-da.
T minus 6. Okay, so now I'm going to use 0 product rule here. So anything times 0 is 0. So now watch this. So it's going to be 0 equals negative 4.9 T. So what is T going to equal? 0. Right here, T equals 0. And for this one, it's going to be 0 equals t minus 6. What would I do to get t by itself? Add 6. So in this case right here, t equals 6. So this equation is telling me that the ball is on the ground 2 times. Does that make sense?
Yes.
Yeah.
So at t equals 0, so that means when I start it, it's on the ground. And then when it lands, it's also on the ground. Okay, good. That makes sense, right? So I have twice where it's going to equal 0.
6 seconds.
6 seconds for this one right here, so yes. What is the velocity of the ball upon impact with the ground? What is its speed? Okay? So we know when t equals 6, that's when it's going to hit the ground, right? So my second derivative, so s double prime t, what do we come up with?
9.8.
Negative 9.8, right? Was there a variable on that one? No, there was no variable, right? No, there was no variable. So that tells me that my s double prime of 6 is going to be negative 9.8. There's no variable, so it just comes out. It's a constant right here.
Could we do-
Velocity is like the second term, so it's not of the.
Okay, so this is second derivative. Velocity, that, because it was asking for, oh, you're right. Sorry. I did acceleration. Sorry. I wrote down the wrong one. Oh, dang it. You're all over the candy today, aren't you? Okay, so there we go. So, all right, so what was it? So velocity was first derivative, and I wrote down second. So s of t, s prime of t. What did it come out to be?
Negative 9.8.
Negative 9.8 t.
Plus 29.4.
There we go. All right, so s prime. So now I said that velocity, right? So velocity, we plug it in, so it's going to be s prime of 6 is going to give me, go ahead, plug it in. What is it?
It's always, because that happened last time too, where the answer was the second part,
That's fine.
because it was 44.
Yeah,
Is
okay.
that pattern?
Kind of, but just on this one, this one's actually made to work out nice and neat.
Okay.
Yeah, it's going to factor pretty. All the rest of them don't. Okay, anyway, all right, so what does that mean? So velocity, now, say what this is. This is going to be what? 4, what are my units?
Meters per second.
Meters per second. So, the velocity is negative 29.4 meters per second. So what does that tell me with the negative?
What's the direction?
It's going down, right? It's going down. So my direction, it's going down at that. So it's coming back down. But now I said that the speed is absolute value of velocity. Okay, so my speed is positive 29.4 meters per second. So when it hits the ground, it's going pretty fast. 29.4 meters per second. So it's basically, it's more than, a meter is more than a yard. So if you think about it in terms of yards, it's going 30 yards every second at that current second right there. So, all right. Where are we at? Impact of ground. What is the speed? Velocity. Okay, so what is the total distance traveled by the ball? Okay, so the distance traveled by the ball on this one, we know that I need to find the what? So the distance on this one. All right, I know it went up, right? Okay, so now think of it like this. So if I walk from here to Douche Bros, that's the distance, right? Okay, but then if I walk from Douche Bros back, what's my total distance?
From here, you're in back.
Yeah. Now, look, my total distance, but if you think about it, I really didn't go anywhere, right? I ended back at the same spot, right? But if I'm going from here to Douche Bros, that gives me a distance, a positive distance, right? But because I'm coming back, that means it's also going to be considered a negative distance, isn't it? So if I have a positive and a negative distance there, then I could actually, it's twice what I did. So whatever it did to go up, it also does to come down, right? Okay, so now we know that it reached its maximum height of what, at when?
3 seconds.
At 3 seconds. So maximum height at 3 seconds, right?
Oh, okay.
So we know in my curve, so if I'm throwing something, right here, this is going to be 3 seconds, right? And I know that this is going to be some maximum height.
44.1.
What is it?
44.1.
So this is going to be 44. Right? So it went up 44.1 meters. And it also, how much does it go down? Same amount, isn't it? So we know that since it goes up 44.1 meters, so therefore it also has to go down 44.1 meters. So my total distance traveled, yeah, is 88.2 meters. Does that make sense?
Yeah.
What about even you guys back there? Not really? Okay.
That last one was so easy.
Okay. All right. So I think that's it. Don't forget, like and subscribe.
Yeah.
Yeah. Don't forget, hit that notification bell.